Welcome, crew. The goal in the next couple of algebraic problems is to use the square root property to solve equations. When you get to the end, I'm looking for exact solutions and solutions rounded to the nearest hundredth if possible. The first one reads -3 times the quantity x minus 2 squared plus 4 equals -17. And with the square root property, our task is to try to isolate the quantity that has the square on it first. To make that happen, we will first subtract 4 from both sides of the equation. That will give us -3 times the quantity x minus 2 squared equals -21. Then divide both sides of the equation by -3. We'll get x minus 2 quantity squared equals +7. At this stage, you can use the square root of both sides of your equation, being very, very careful. We will take the square root of x minus 2 to the second power and set it equal to plus or minus the square root of 7, the right-hand side of the equation. We need to capture both the positive and the negative square root here. And you have to remember to inject that little step. When you take the square root of x minus 2 quantity squared, you are left with just x minus 2. And on the right-hand side, you're left with plus or minus the square root of 7. We'd like to get x all by itself. We will add 2 to both sides. And one way to write this final step would be x equals 2 plus or minus the square root of 7. The square root of 7 does not simplify nicely. It's an irrational number. And so these two results would be your exact solutions. For solutions rounded to the nearest hundredth, we'll take our statement and split it into two equations and then grab a calculator. X equals 2 plus the square root of 7 and x equals 2 minus the square root of 7. We'll get a couple of approximations for these. On the calculator, make sure you can see it. 2 plus square root of 7. That gives us, to the nearest hundredth, 4.65. And then 2 minus the square root of 7 gives us -0.65. So we get two solutions to this equation. Let's talk about whether that makes good sense or not. The original statement, -3 times the quantity x minus 2 squared plus 4, that is really, if we think graphically, that's a quadratic function in vertex form. And the vertex would be 2, 4. And the parabola would open downward. So if I make a quick sketch, if I have a vertex of 2, 4, and the parabola opens downward, and my scaling might not be very good here. We don't need to worry too much about that. What we're doing graphically is saying, okay, we want this left-hand side of the equation, the parabola, to cross the right-hand side of the equation, or the horizontal line, -17. I'm going to put some ellipsis dots here on my y-axis, and then put in the horizontal line y equals -17. And in the picture, if your parabola is opening downward, there are two places where your parabola crosses that horizontal line, and those would be coming from your two answers. So it makes good sense that we got two answers to this problem. In the next one, you're asked to solve 5 times the quantity x plus 1 squared plus 2 is equal to 1. And we'll proceed the same way that we did before. Subtract 2 from both sides. 5 times the quantity x plus 1 squared is equal to -1. Dividing both sides of the equation by 5 gives us the quantity x plus 1 squared is equal to -1/5. To undo the square on the left-hand side of the equation, we'll take the very careful square root of both sides of the equation, so that the square root of x plus 1 quantity squared equals plus or minus the square root of negative 1/5. And when you get here, you should notice here we're trying to take the square root of a negative number. And there are a couple ways to handle this. The first, most basic way is to say there are no real solutions to the equation that we started with. If you are in a class where you are working with complex numbers, then there are other ways to handle this result. For right now, if we were just trying to solve this and I was worried about the real number solutions, we do not come up with any because of this square root of a negative number. Let's take a look and see conceptually if this makes good sense, or graphically. The original statement essentially asked you to take a look at the intersection between a parabola and the horizontal line y equals 1. The parabola over here on the left had a vertex of negative 1, 2. So just quickly graphing that in here, negative 1, 2 for a vertex. And then the parabola is supposed to open upward because of the positive a value. And we want that parabola to cross the horizontal line, y equals 1. Well, y equals 1 is under the vertex of the parabola that opens upward. And so there are no places where the parabola crosses that horizontal line. So no intersections of these graphs indicate that we shouldn't get any real solutions to the equation. That's a good sign. It means that we're headed in the right direction.